This is Dr. Miller again, going over the pre-lab for lab activity 6.2 that's due 4:30 on October 3rd, which is a Thursday. So we have 3 questions, and they are qualitative questions instead of numerical questions. So which property or properties do you think will be most helpful for classifying the elements as metals, nonmetals, or metalloids? Explain your reasoning. So let's look at the data you're given in the lab procedure. So we have, this is on page 182. So let's look at, I showed you real quickly the cards, but this gives you a little bit more details about it so you can answer that question. So the question is, we want to look at something that helps us decide whether or not something is a metal or a non-metal or a semi-metal. So no, metalloids, I'm sorry, metalloids. So we are getting the discovery date. So that may or may not be helpful to you for distinguishing the different types of elements. Physical state at 25 degrees Celsius and 1 atmosphere. Well, I will tell you that most metals, almost all of them except for one, is a solid at room temperature and 1 atmosphere. So there's one that's a liquid, that's mercury. So if that might help you decide whether something's a metal or not. And then atomic volume, whether that will help you or not. Thermal conductivity. Well, we know that metals do conduct heat. You don't want to pick up an aluminum pan on the stove without a hot pad. If it's still hot, if it has an aluminum handle, you don't want to do that because the heat will transfer very easily to your hand. So we do know that metals have thermal conductivity, and things like oxygen would not have much thermal conductivity, so that might be a help. It says in metals, lattice vibrations are accompanied by the movement of mobile electrons, so metals tend to have a higher K value, which is the measurement of thermal conductivity. And so there is also a chart here that tells you the approximate range of thermal conductivity. So we can see non-metals really don't have conductivity. Semi-metals have some, but look at the metals, they have a lot. So ranges from 450 down to 1. So this information could help you. So I would probably include this, thermal conductivities, as a help as to whether I'm going to classify something as a metal or non-metal. Then we would look at going on to melting point and boiling point. Metals tend to have very high melting points, hence that's why they're solids at room temperature, whereas nonmetals tend to have low melting points. There are some exceptions. So a nonmetal would probably be a gas, or would be likely to be a gas or a liquid at room temperature, so they have low melting points. And so that might be helpful there. Let's go on to the next page, 184. And doesn't look like anything else except in the hydrates and oxides may or may not help us. So that may or may not be information you need for this particular question about whether it's a metal, non-metal, or metalloid. So we go on to nonmetals on electronegativity. So that's the tendency of an atom to draw electron density towards itself in a chemical bond. So nonmetals tend to have very high electronegativity. Group 1 and 2 metals, we can even get more distinguishing here. So nonmetals have high electronegativity, and metals that are group 1 and 2 have low, and main group and semi-metals have somewhere in the middle, and transition metals have a broad range. Electron affinity, let's see here. It doesn't look like that would help us a whole lot with this particular question. And so ionization energy then, here we go. This is talking about metals here. So whenever you see the word metals or non-metals in the preliminary discussion, or actually this is the procedure for the lab, I would say, okay, we're going to use that information to help us know whether it's a metal or non-metal. and this doesn't address the metal or non-metal. And then here we have something, I don't see anything about non-metal or metal there. And then here we have electron configuration. So this would help us with another question. So those are probably the ones that will help you with question 1. So now let's go to question 2. Which property or properties do you think would be most helpful for classifying the elements according to group? Now the group is the column in the periodic table. So we did see something about group 1 and group 2 metals and the transition metals, and then we saw something about the whether it reacts. So let's look to see what would help us put it in a group. Groups react similarly. So for instance, when I pointed out that whether an element reacts with 3 hydrogen or just 1 hydrogen, one group would react with 3 hydrogens. That would be a group, the column going down. And then another group, a different column, would react with just 1 hydrogen. So something like that would be very helpful according to groups. So let's look at the data here. So turning over to page 182. Let's see. Don't see anything really that would help us with that. Here though, under hydrides and oxides, just the hydride that produces the lowest oxidation number and the oxide that produces the highest oxidation number. So if the oxidation numbers are different, then that would be how many oxygens something combines with. So the different numbers would help us put them in different groups. If there's no hydride or oxide listed, you can assume they don't form with the element in question. So that might be that would be helpful too, that we could put those in a group, in a column. So I don't see anything else here. Here we're talking about left to right. Okay. Okay. Let's see here. Okay, ionization energy tends to decrease from top to bottom in a group. So once you have a group, that might help you. And let's see here. Atomic radius tends to increase from top to bottom down a group. Okay, so there we could not only put them in a group, but maybe organize them in a group, not just putting them in clubs or hearts or diamonds, but start to organize the ace and then the king and then the queen. So that would help us to organize the group once we decide what group they're in. And let's see here. Let's see here. Okay, this, if we had electron configuration, that would help us with the group, wouldn't it? So we have the 1s in then the 2s, then the 3s. So if it has an s in it, if it ends in an s, that could be a certain group here, sort of, it would be 2 groups. Here if it ends in a f, that would be the f block. So we have ways to group things here. If it ends in a D, that's the D block, and if it ends in a P. So once you get the electron configuration, you can look to see what one it ends with, and perhaps that would help you put things in a group too. Okay, so that's question 2. So then question 3, which property or properties do you think will be most helpful for classifying the elements according to a period, a row in the periodic table? So as you go across, there are trends as you go from left to right within the same period. So the periods are the same row. So things change as you go left to right. So you don't want to have things out of order as you go left to right. So you want to have the right order because it's a table. It not only has the columns, it has the rows. So let's look to see what information might help us with that. Okay, so atomic volume. Okay, so as you go across, perhaps the volume changes. So you would look to see, once you have things in groups, you can then go see, well, can I put something in the same row as it kind of, it just smallly goes up just a little bit at a time, or goes down a little bit at a time as I go from left to right. Maybe they go up, maybe they go down, but it'd be very small changes across rather than jumping from one row to another row as you go across the periodic table. So let's see here. Okay, perhaps density might be one of the things that changes as you go across the period. So you would want to look at the density data and see if that would help. Let's see. Oh, here we go, right here under electron affinity. The magnitude of electron affinity increases from left to right across the periodic table. That's the amount of energy released when an electron is added, and it increases as you go from left to right across a period. So that would help you organize the periods, electron affinity. Let's see. Now here, this would help us too. We know metals are on the left-hand side of the periodic table, so this is under ionization energy. This is the section that's ionization energy, the energy it takes to remove an electron. And metals tend to have lower ionization energies than nonmetals in the same period. So as you go across the row, the ones on the left are going to have lower ionization energies than those on the right of the same row. So that would help organize them too. And then here's another one. Covalent radius. So the radius decreases from left to right across the period. So it gets smaller as it goes from left to right across the period. So even though the mass increases from left to right, the radius decreases from left to right. I'll just tell you why. It's because you have more protons, and the more protons can pull those electrons closer. So even though you have more electrons and more protons and more mass, as you have more protons, the electrons like to snuggle up to them, so they get smaller as it goes from left to right. Okay, so then let's see if we find anything else here. So here we have, as we go from left, we can see that we need to put the two S's and the two P's together in the same period. The three S's and the three P's. The four S's, the three D's, and the four P's go in the same row. So electron configuration will also help you with the periods. So that concludes our pre-lab activity. Hope you can figure those out. Let me know if you have any questions at jmiller5@mvnu.edu.